Hello there, this is Daniele from Toolchefs and welcome to this new video. Today we're going to have a look at the context steering module, which is a module based on the context steering algorithm which is used in games. This algorithm is used for finding the best direction for an agent based on different inputs. So as you know, we can have in crowd different scenarios. For instance, an agent could be walking among other agents. It should avoid these agents, but also should also avoid obstacles like meshes and so on. And it can be quite hard to find the best direction for each agent, and also the velocity of each agent based on one single input, which could be, for instance, the proximity of other agents. So that's why the context steering algorithm was invented, to kind of solve this scenario. The context steering works in this way. So each agent fires a number of rays that is defined by the user, and the origin of each ray is the actual agent. And then, depending on these rays, basically the context steering will fill two different maps. One is called the interest map, and the other one is called the danger map. So the interest map contains the preferred direction for each agent. So for instance, in this case, we have two targets, and this agent sees that this target is closer than this other target. So it will fill a higher value for this ray in the interest map, and it will fill a lower value for the target that is over here, for this ray, for the target that is over here. And at the same time, also a danger map is going to be filled, so we're going to have a higher value for this ray, for the danger, because this obstacle is closer than this other obstacle over here. Then depending on the values that are contained by these two maps, each agent will find, the context steering will find for each agent the best direction to take. And now let's have a look at the context steering module. Okay, so here in Maya, I've already created a scene. I've laid out some agents. I've attached the locomotion module, and I've set an initial linear velocity with another metadata. Then I've created some directional modules. So we have a curve field. We're using these two curves, and these are giving the main direction to our agents. Then we have three mesh avoidances to avoid these three cylinders, and one agent avoidance to make sure that the agents don't intersect during the simulation. As you can see here, as the last module, we have the context steering. It's fundamental that you always add the context steering at the end of the stack, and make sure it's always at the end of the stack, because it uses all the results from the previous modules to compute the optimal direction for each agent. So if you place it higher up, then you're probably gonna miss some of the results of the previous directional modules, and most likely the following directional modules are going to overwrite the result of the context steering. So once again, always put the context steering at the end of the stack. Let me filter out just one agent so we can see what's going on with the context steering. So I'm going to activate the debug, and as you can see here, the context steering module is drawing the rays that we are discussing in the previous slide. Here we have some attributes. So this number of samples is actually the number of the rays. So we could say even 16 or 24. With more rays, you have a more accurate result, but it's always also slower to compute. Then we have the max turn angle, which is basically the same value that we use for all our directional modules. As you know, each agent at each frame could find, could be traveling following this direction, but then at the next frame, it's finding the next optimal direction to be this one. The angle between these two rays is quite large. It is basically around 90. By providing a max turn angle of 8, we're making sure that at each frame the agent can just turn of 8 degrees. So you're gonna have a smoother transition. We also have the angle threshold. I'm gonna jump just quickly the danger threshold, but I'm gonna come back to it just in a second. The angle threshold defines the angle that is used by the context steerings to fire up the rays. So if you use 90, you're gonna have, let me just do 90, you're just gonna have 180 degrees. The degrees are gonna cover a 180 angle, but if you wanna do the full 360, you can use the 180 like this. So for the angle threshold, for the angle threshold, you can also use a metadata to drive that value if you want. Then we have the max distance, which is basically the length of the rays. So you could say 300. Or we can just use 200. And the danger threshold is used in combination with the max distance. They're basically going to be multiplied with the danger threshold is going to be multiplied by the max distance. And whenever the danger value for one of these rays is going to be higher than this multiplication, then that direction is going to be ignored. Here we have a velocity threshold, which you can enable or disable, but basically whenever the agent is traveling at a linear velocity lower than this value, then the context steering is going to do nothing. Alignment at init frame will make sure that the agent is going to be aligned at every frame. Then we have the locomotion section, which is similar to what we have already in another directional module. So you can decide if you want to modify the angular and the linear velocities. You can provide a minimum value and a maximum value for the linear velocity. So if you say 130 here, which is the value for the walk, you're just gonna say I never want the agents to go faster than a walk. So basically it's just gonna be either in idle or gonna just walk. So or it's gonna blend between these two clips. The negative linear velocity is whenever the target is behind the agent, then we're going to use this value as a maximum value for the linear velocity. Then here we have the fall-off radius, which is used whenever the agent is going to follow a target. So whenever it's become closer than 100, it's going to start slowing down and using, blending between the maximum and the minimum velocity. And then once it reaches the target distance, then it's going to just use the minimum value. Finally, we have the max linear acceleration. This value is used for clamping the linear velocity, so the metadata that is driving the linear velocity, which is this one, target linear velocity at every frame, and is a bit different than the value that you have already on the locomotion module. This is because in the locomotion here, the maximum linear acceleration is actually is used internally within the graph of each agent. So we don't actually clamp the metadata itself, but with the context steering with this max acceleration is actually gonna clamp the metadata. So this is basically just why you see a max linear acceleration here. So if I now actually let me first do this so I can explain a bit what's happening here during the debug. As you can see here, we have already some rays. So the green one are the interest. So now the agent is saying, oh, I can go anywhere here. So basically all these rays have a kind of like a similar interest up here. These ones have a lower interest because they're not parallel to the current direction. Then here we have the red ones are the danger values, and then we have the yellow, which is the result. So as you can see here, these two rays, the yellow ones, are shorter than compared to the others because we have some danger values, and also you see that this ray here is slightly shorter than this other one, and this is because this ray here has a higher danger. So basically, based on the result that we see here, we know that the agent is gonna basically turn into this direction and it's not going to turn right, simply because it would actually be going towards some danger. So let me show you all the agents and the simulation, and we have separate videos for the avoidance if you want to build more complex example, but this is basically, as you can see here, I've set up each mesh avoidance, each module, directional module separately, and then the context steering is doing all the hard work just to make sure that the agents avoid each other, follow the main direction, and also avoid the meshes. So I'm just gonna press play and we can see the simulation. And this is all for this video. Thanks for watching.